All right, here's your lesson on solving trig equations. We're going to start first with a graph. Could you graph sine x below? Starts in the middle, goes to the top, back to the middle, goes to the bottom, back to the middle, and you have your wave. The question is, give the solutions for the equation sine x equals 1/2. So at what angle does the sine 1 equal 1/2? So if I look at that, understand, if I drew this, that there's actually two solutions. One solution is here, and that solution is at pi over 6. It's also a reference angle, so I know that. And the other solution is over here, and I know that solution is at 5 pi over 6. So there are two places where that answer is true. And the other challenge is this wave goes on forever, both directions. So there's an infinite number of solutions. So to write this solution, we have to understand, first, find the angles from 0 to 2 pi. But then we have to write it generically. And to write it generically, we're going to write down 2 pi times n. And that n is any integer. So again, plus 2 pi times n. So what I did is I took that angle, and if I go a full circle, I come right back to that same point on the circle over and over and over again. Same thing with 5 pi over 6. And this is a way to write the answer generically, where n is any integer. So a trig equation can have one solution, no solution, or several solutions, depend on the interval. To solve a trig equation, isolate the trig function. All right, so we're going to practice this. And I know it's uncomfortable at first, but we'll get it. So step one, can you isolate cosine x? That's what I want by itself. So to do that, first of all, I see there's a cosine x on the right and a 5 cosine x on the left. So to combine like terms, I'm going to subtract 3 cosine x. So that leaves me with 2 cosine x plus root 2 is equal to 0. Then, to solve this, I still need to get cosine x by itself. So I'm going to subtract root 2. And then I'm going to divide by 2. So now I have the trig function by itself equaling negative root 2. I know it goes with the x-coordinate. So the x-coordinate's negative root 2 over 2. And the y-coordinate must be positive or negative root 2 over 2. This does not fall under the restrictions of inverse trig. So what are the angles in the from 0 to 2 pi that's true for? So what's the reference angle? What quadrants are we in? So for negative, we're in quadrants 2 and we're in quadrant 3 when cosine's negative, the x-coordinate. So for 45 degrees, that's over 4. What are the radians in quadrant 2? That's 3 pi over 4. I'm going to leave a space. I should have left a space. And then I have to add 2 pi over n, and then the other one is 5 pi over 4, and again I have to add 2 pi over n, where n is any integer, and then you have all the solutions. Let's try that again. I want to isolate tangent, so I have tangent on the right, tangent on the left. It'd be nice if it was positive. I'm going to add 3 tangent, so 3 plus 3 is 6. And then I'm going to subtract 2 root 3. So when I subtract 2 root 3, we have like radicals, so 8 take away 2 is 6 root 3. Divide by 6, so tangent theta equals root 3. There's my equation. So what would the angle be then? So in this situation, know the reference angle. So for root 3, it's a 60-degree reference angle. It's positive. Know which quadrants tangent know what quadrants tangent's positive in 1 and in 3. So in quadrant 1, it's pi over 3 and then 2 pi n. Or in quadrant 3, it's 4 pi over 3 plus 2 pi n. And n is any integer. So that we've covered every solution possible for that equation. Number 3, cosecant. Hey, this is alpha, just so you know. It's a Greek letter like theta and pi and so on. There's a new letter for you. So alpha, cosecant alpha. I want to get that by itself. So first step is multiply both sides by 4. Next step to get cosecant alpha by itself is add 6. Negative 4 plus 6 is 2. And then I think it's easier to do the reciprocal of that to understand it. So the reciprocal of cosecant is sine, and that's 1/2. So what reference angle is the y coordinate 1/2? And that means the x is positive or negative root 3 over 2. So that reference angle is 30 degrees. It's positive. So what quadrant are we in? So we're in quadrants 1 or 2. So 30 degrees, quadrant 1, pi over 6 plus 2 pi n, or 5 pi over 6 plus 2 pi n. Number 4, combine like terms. So subtract secants, that's 6. Divide. I'm going to reduce it down and then do the reciprocal. So the reciprocal is 3 over 2 root 3. Rationalize it. Now when you multiply by root 3 and root 3 times 2, that's 6. So if I reduce it down, that's negative root 3 over 2. So it's finally a fraction I understand. That is a 30 degree reference angle. And what quadrants are we in when cosine is negative? So we're in quadrant 2 and quadrant 3. So that would be 5 pi over 6, 2 pi n, or 7 pi over 6. And again, n is any integer. But I'm not going to make you write that down over and over again. Number 5, big A. Get tangents together. Subtract 1. So 3 subtract 1, that's 2 tangent A, combining like terms. Divide by 2, and you get negative 1. That's a 45 degree reference angle when tangent's 1. But where is it negative? So it's negative in quadrant 2. So that would be 3 pi over 4. And again, add 2 pi n. Or quadrant 4, that would be 7 pi over 4. And then 2 pi n. And again, n is any integer. Oh, we just want the answers from 0 to 2 pi. So they changed the domain restriction. So because of that, we don't need this extra part at the end. What are the two angles from 0 to 2 pi that works? And the answer is 3 pi over 4 and 7 pi over 4. Number 6. Combine like terms. So that's what I'm going to do. So I'm going to subtract 8. 11 subtract 8 is 3. I'm going to divide by 4. And then I'm going to take the square root. Now I know when I take the square root, it's going to be positive or negative root 3 over 2. Just taking the square root of the top and the square root of the bottom. So what reference angle is that? So when the y coordinates root 3 over 2, that's 60 degrees. Positive or negative in what quadrants? So from pi to 3 pi over 2 is only quadrant number 3 in that domain restriction. So what's the angle in quadrant number 3 that satisfies us? So 60 degrees, so the answer would only be over 3, 4 pi over 3. Turn the page. So now we're going to do some algebra solving. So to solve this, again, I'm not even going to factor this because we only have cosecant squared. So step 1 is to add 1, then to divide by 4, take the square root, so that's positive or negative 1/2. And then what's that? All quadrants. 1, 2, 3, and 4. So what reference angle is that? If the x coordinate's 1/2. That's 60. So all angles, that's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So it's all 60 because it's 0 to 2 pi, positive or negative. So that's all the reference, all the angles in terms of 60 degrees. Number 8, factor. So I can tell that, first of all, I need to make it equal to 0. So I'm going to subtract cotangent. Then I'm going to factor it out. So both have a cotangent x. So factor it out, and what you're left with is sine squared minus 1. Each one equal to 0. When is cotangent equal to 0? And when is sine squared equal minus 1 equal to 0? So for this one, we're going to add 1 and then square root. Now when you do the square root of 1, the answer is going to be positive or negative. I need to know the quadrants. From pi to 2 pi is quadrants 3 and 4. So where is cotangent 0? And so cotangent by definition is x divided by y. So when is the x coordinate 0? So the x coordinate is 0 at pi over 2, but that doesn't work. And the other one is at 3 pi over 2. That does work. How about here? When is sine positive or negative 1 in the quadrants there? So when is the y? Now, 3 pi over 2, sine is negative 1. It's never positive 1 for quadrants 3 and 4 because it's in the bottom of the circle. So the y value is negative below. So the only answer for that is 3 pi over 2. Again, the answer key anyways, I only get 3 pi over 2. I don't get, I know they did a trig identity when they did that. I'm trying to think of what they did in terms of that. That was different than what I did. They subtracted that equal to 0, factored out cotangent. All right, I'm going to stick to here. So where is sine positive or negative 1? That's at the top of the circle at the bottom. So the only one I would get is 3 pi over 2 in terms of how I factored it. I'm trying to think what I might have factored wrong when I did it. I don't know. It looks like it's right to me. My only answer is 3 pi over 2. Number 9. So solve this by factoring. They both have a tangent. And you're left with 3 tangent u minus root 3 equals 0. Take each one equal to 0. Now for the first one, we're good. This one I need to do some work on. I need to add root 3 and divide by 3. So now I need to know my domain restriction. So that's only quadrant number 3, from pi to 3 pi over 2. Where is tangent 0 there? And pi is included, so pi is a good answer. So at pi, when you go y divided by x, the answer is 0. The other one, where is it positive root 3 over 3? So that's quadrant 3 again. And what reference angle is that? So that reference angle is 30, so it's 7 pi over 6. So the two answers are pi and 7 pi over 6. I agree with the answer key. All right, number 10. Combine like terms. So I'm going to subtract root 2. So 2 subtract 1 leaves me with 1 root 2. Now it's equal to 0. Factor out a sine x. So you have secant x plus root 2 equaling to 0. So we have sine x equals 0. And then the other one we have secant x plus root 2 equals 0. So I'm going to subtract root 2 to get secant by itself. And then I'm going to do the reciprocal so I can understand it. And the reciprocal of that, when you rationalize it, is negative root 2 over 2. So what does x equal in this situation? So when is the, and it's from 0 to pi, which is quadrants 1 and 2. When is the y coordinate 0? So the y coordinate is 0 and at pi. How about for negative root 2 over 2? What reference angle is it in? And it's in quadrant number 2, so it's going to be over 4, it's going to be 3 pi over 4. And you have all your answers. Number 11. I'm going to add cosecant theta. I can't combine like terms. Subtract 7. So 5 subtract 7 is negative 2. I can't combine them, but I can factor it. So if you want, you can let x equal cosecant theta on the side. By doing a substitution, then you might feel more comfortable factoring it. So what is the factoring here? Two numbers that multiply to negative 2 and add to 1. So that's x plus 2 and x minus 1. So one answer is negative 2, and the other answer is 1. Now you can plug back in. So that means cosecant negative 2 and cosecant 1. Now I'm going to do the reciprocal. So the reciprocal here would be negative a half, and the reciprocal here would just be 1. And then I need to know what quadrants. That's only quadrant number 4. So in quadrant 4, where is the y value negative a half? So that's a 30 degree, so that's 11 pi over 6. Where is, oops, I should say sine. Where is the sine value 1? And because I see it, there is no spot where it's equal to 1. So it's only this. So there is this one, doesn't, in the domain restriction, there is no angle that would fit that. It would be at the top of the circle, which is at pi over 2. Number 12. So for this one again, I'm going to let x equal sine alpha. So I can just write down 2x squared plus 3x minus 2 equals 0. 2 times negative 2 is negative 4, and 3. The two numbers that multiply to negative 4 and add to 3 are positive 4 and negative 1. And then when I factor this, I'm going to factor by grouping. So I have 4 and negative 1. And then I factor out a 2x, and I get x plus 2, a negative 1, and I get x plus 2. So I have x plus 2 and 2x minus 1. I'm going to solve for x and then plug back in. So x would equal negative 2. So one answer is sine alpha equals negative 2. Now that's not possible because it's beyond my restriction. The next one is 2x minus 1. So when I solve for x, I get positive 1 divided by 2. Now sine alpha can equal 1/2. So that's in quadrant 1 and all the quadrants, but sine is positive in 1 and 2. And what's the reference angle when the y value is 1/2? So it's 30. So at 30 degrees, it's pi over 6, and then the other 30 is at 5 pi over 6. Quadrant 1 and 2, where sine is positive. All right, 13. Now, we're going to end at 14. We're not going to do questions that involve using different identities to be able to solve it. So we're going to end at 14. So 13. Can we solve this? So again, it might be helpful to say x equals secant x. So that, actually I need to use a different letter. So y equals secant x. We already have x. So that'd be y to the 4th minus 4y squared plus 3, and then y squared minus 1. To make the algebra simpler, combine like terms, so subtract y squared. Negative 4, subtract 1. So add 1, that's 3 plus 1, that's 4. And then factor it. So when I factor this, the two numbers that multiply to 4 and add to negative 5 are negative 1 and negative 4. Then when I solve it, the answer is going to be positive and negative 1. And on this side, when you solve it, add 4 and square root, it's going to be positive or negative root 2. Then put in secant. Now the reciprocal of that, cosine, is positive or negative 1, while the reciprocal of this is 1/2. And then it says, what quadrant is pi to 2 pi? That's quadrant 3 and quadrant 4. So start here, and the ends are included. So negative 1 and positive 1, that's pi and 2 pi. For 1/2, what's the reference angle for 1/2? For the x coordinates, that is 60 degrees. That's over 3. And in quadrant 3, that's 4 pi over 3. And then in quadrant 4, it's 5 pi over 3. Last one. So again, I'm going to let tangent y equal x to make it easier. So it's x cubed plus x squared minus 3x minus 3 equals 0. Then I'm going to factor by grouping. So I'm going to factor out an x squared, factor out a negative 3. So I have x squared minus 3. I have x plus 1. So if I solve this, x minus 3 equals 0. Add 3 and take the square root. You get positive or negative root 3. Now put tangent back in. For here, subtract 1, and then again put tangent back in. I'm going to run out of space here. What's the quadrants? Quadrant 1 and 2 only. So for positive and negative root 3, that's a 60-degree reference angle, y over x. So that is over 3. So that's pi over 3. How am I going to write the answer? Here, I'll write the answer here. So that is pi over 3, and that is for positive or negative. Oh, and that's also 2 pi over 3. Where is it equal to negative 1 only? Just negative 1 is in quadrant 2, and that's 3 pi over 4. And those are your 3 answers that satisfy that equation. This is going to take practice and really, really, really knowing your unit circle. I believe in you. There's the lesson. Now you get to practice your homework and ask me questions so I can help you get through these challenges. Mr. G Math, over now.